Transportation in the United States is expected to change radically in response to economic factors, fluctuating oil availability, and environmental constraints. The choices, the skills, and the imagination of today's youth will define the transportation systems that emerge in the 21st century. As scientists and engineers, they will develop new vehicle and fuel technologies. As citizens, they will make decisions balancing mobility, environmental, and economic need. Junior Solar Sprint challenges students to use scientific know-how, creative thinking, experimentation, and teamwork to design and build high-performance solar electric vehicles. The Junior Solar Sprint program offers teachers and students a creative approach to learning. It is a hands-on, product-based program that is both interesting and rewarding. The results of a student's thinking, teamwork, and problem-solving skills are readily seen in the finished product, as well as throughout the Junior Solar Sprint project.
Drivers, on your mark, get set, go! We've got some competition here! We've got some race!
Junior Solar Sprint is a national program that was begun in 1990 by the U.S. Department of Energy at Argonne National Laboratory at the University of Chicago. It is endorsed by the National Science Teachers Association and is hosted by the Society of Automotive Engineers, the National Renewable Energy Laboratory, the Florida Solar Energy Center, and the University of Central Florida. Junior Solar Sprint is a science class-based program for middle school students. Working in teams, guided by a teacher or mentor, the students design and build a solar-powered, model-sized vehicle. Incorporating a multidisciplinary approach to learning, the Junior Solar Sprint program offers challenges in science, math, and engineering. Using the science of solar power and electricity, students learn how to create and use a simple form of energy. The sun and the solar panel provide the necessary energy to power the vehicle.
Oh, the power comes from this 3-volt solar panel. As you can see, the silicone panels from the inside and all the connecting wires.
It went through the wires to the motor, which turned the gears and made it go.
Students use their knowledge of math to design the vehicle and to help them determine the proper gear ratios for propelling the solar-powered car.
Gears are connected to the axle, which makes the wheels turn when the engine runs, which occurs when the sun hits the solar panel.
We had a bigger gear on the axle and a small gear on the motor because the motor didn't really have much guts.
We have a gear, 2 gears on here. The little one makes the big one run, and it turns the motor, and the motor is connected to one of the wheels, and one wheel goes and then all 4 of them go when it's on the ground.
There's different ways to move the axle. There's not just one.
Go!
Putting it all together, constructing the frame, attaching the motor and the wheels, and securing the solar panel to the frame takes some engineering skill on the student's part.
I think one of the most difficult things about building our car and stuff was to get it to stay, the glue. We had to have glue, we had hot glue, and we had like epoxy and stuff.
The hardest part about building the car was building the frame because you have to have it directly straight.
How I should fit the gear into the tire where the axle is, whether I should mount it forward or backwards, giving me enough room.
Also, the wheels were a big problem. Because like we would try plastic wheels and then it wouldn't run, and then
We tried some heavier wheels and ones with less traction, but they didn't work as well because it couldn't catch onto the ground and go as well.
And I was thinking what would be best for aerodynamics on the car.
The place you put the solar panel, if there's air resistance or any place where the wind comes in, your car might slant and wind the other direction.
The Junior Solar Sprint program promotes a creative approach to learning that requires critical thinking in engineering, science, and math. It is a hands-on program that is both interesting and fun for the students to participate in. Junior Solar Sprint is a product-based, goal-oriented effort. With teamwork being critical to the success of the project, Junior Solar Sprint promotes the sharing of ideas among team members, and it promotes a shared level of responsibility among the students. The students must draw on their individual and collective skills to identify problems and create effective solutions to those problems. They must solve problems like how to get the solar power to the axle, how to create an aerodynamic vehicle with enough weight to support its elements, yet light enough to move fast, and how to create an aesthetically pleasant yet functional car.
I think teamwork has a lot of it too, because with this car you really had to work as a team with all the other girls.
The strength that I brought was determination. I think all of us had a will and wanted really to do the car and get it done, but I like to get things done fast.
We all probably had about the equal amount of strength because we all helped in building the cars and all helped race in the competition.
I'm very competitive, and so I would always encourage my friends to try to build faster and better cars.
Aerodynamics is used on most cars to help them go down like highways and stuff faster. And we used aerodynamics in all of our cars by making a slim design pointed to cut right through wind and stuff.
I learned a lot from the car. I mean, when it runs along the islet, I could have moved this over and moved the tire over to make it go straight instead of curve. And
when we were there, we saw so many different cars and stuff that worked better, and the winning car had like everything was light.
I've learned that the less weight runs faster.
The winning car just flew. It was really interesting to see though.
The science of solar power, tied with the mechanics of motion, gives the student an avenue to new ideas and concepts. Concepts that are apparent in real-world applications of solar technologies within our own communities. Ideas that apply and promote energy awareness and energy efficiency in our everyday lives. These can open doors to long-term habits that are environmentally friendly.
Now that we worked with this car, I realized that solar power is really helpful in everyday life and what an asset it is.
I like electricity, and solar panel that produces electricity are very useful for me and for the daily life.
I'm more surprised of how good solar panel energy is, how good it can run.
I believe the solar panels are a very good idea to generate power, but we still cannot waste.
The Junior Solar Sprint competition is held annually. It is a statewide competition held at a central location. Past competitions have been held at Walt Disney World's Epcot Center, the United States Astronaut Hall of Fame, the University of Central Florida, the Florida Solar Energy Center, and the Orlando Science Center. On the Junior Solar Sprint race day, students are given the opportunity to have their vehicles judged on design, innovative use of materials, and performance. Each car goes through a technical inspection to verify compliance with the rules. The cars then compete in the track portion of the event. The vehicles race until 3 winning teams in each category are determined. At these competitions, the students see the results of their efforts materialize. They see the planning pay off, they see the teamwork pay off, they see the results of their labor pay off.
I like the competition the best with how they had run it with the double elimination. Say something went wrong the first one, you can go back and try it again.
The final product, you worked so hard and everything to build the car and try to see who was faster, and it was like a healthy competition kind of thing.
We learned a lot about solar panels and how it works, and we had a lot of fun doing this.
You all did an outstanding job. The fact that you took this on as a project tells me a lot about how industrious you are. And thank you. You did a great job, every single one of you that built a car and came out here to race.
The Junior Solar Sprint program helps to build creative thinking and shows students that learning can be fun. Students learn by doing. For more information on Junior Solar Sprint, contact the Florida Solar Energy Center at 321-638-1000 or find us on the World Wide Web at fsec.ucf.edu. The Florida Solar Energy Center is a research institute of the University of Central Florida.